This video will discuss chapter 8-9, prediction equations. So this chapter is going to do a lot with scatter plots and lines of fit. So I'm going to show you a couple of graphs in the book, and I want you to kind of pay close attention to the, to the graph of this. And so the idea here, and pretend for a second that this line doesn't exist, you would take this table showing you the number of college-bound students that took the ACT in 2000, 2002, 2004, 2006. And so you can see that this is the number of students, obviously in thousands, and then this is the year. And so the idea is that we're taking these points and we're going to plot them onto the graph. And then once you've plotted them on the graph, what you're going to do is figure out a line that essentially kind of goes through those points. And what you'll notice is that it doesn't necessarily have to have the same number on top or above the line and below the line, but it kind of tells the story. So I could ideally remove all 4 points, and this line would kind of tell me what's going on in this graph. Okay, and then once you've drawn this line, and you'll see the question that it asks here is that it's going to ask you how many students would you predict are going to take it in 2015. And so if you were to use this line, you could come over to 2015 and try to figure out exactly, or not exactly, but use this to predict what you think would happen. Now keep in mind this is just a prediction. It is not necessarily always going to be true. And in fact, we'll talk in class about some examples where it doesn't work. But it is the idea, and a lot of businesses and companies and all sorts of other areas use these prediction equations to try to figure out what it is that they want to do to help them make wise decisions. Now, the second example that I want to show you is up here, and this has to do with movie theaters and screens. We're going to actually use this one to figure out the line. So again, pretend that the line is not there. Try to get this page to stay out of the way. I'm going to move the camera for a moment. Okay, and so I'm looking at now the movie theater screens. I want you to, not counting those 2 points, the 237 and the 638. If you were to take those two out for a moment, you see that the line kind of goes through and tells exactly, or a little bit of what's going on. Now I'm going to use those 2 points, 237 and 638, because now what I'm going to do is try to use this line. I'm going to find the equation for this line, and then I'm going to be able to use it to predict what's going to happen in the future. So, using those 2 points, I'm going to try to get you back on track. All right, so I'm using these 2 points. And what I'm going to do is try to figure out what is the equation for this line. So I know that the equation holds these 2 points. So first thing I got to do is find the slope. So I'm going to go x1, y1, x2, y2. And so this becomes 38 minus 37 over 6 minus 4. Right? Y2 minus y1, x2 minus x1 gets me to here. Now this is 1, sorry, over 4. I was already doing the math in my head, my fault. 6 minus 2, right? X2 minus x1, I'm sorry about that. So then this becomes 1 over 4. And I'm going to actually end up, and I know that I tell you all the time not to use decimals and not to use decimals, to use fractions, but in this particular example, I'm going to actually end up using a decimal because we're going to use these decimals to help us find something else. So now I've got to use my formula for point slope. So I'm going to use x minus x1, I'm sorry, y minus y1 equals m times x minus x1. Right? So this is my point slope. Y minus y1 equals m times x minus x1. And so this is going to be y minus, I can just use this point, y minus y1 equals the slope, which is 0.25, times x minus x1, which is 2. Right? And then from here, I'm going to end up trying to get it so it's y equals mx plus b. So I need to distribute. So this becomes y minus 37 equals 0.25x minus, now I'm going 2 times 0.25, right? And so this is 0.5. And then I want to get y by itself, so I'm going to add 37 to both sides. And so this becomes y equals 0.25x plus 36.5. So I now know that that is the equation that I can use to predict the number of movie theaters, or number of movie theater screens in the U.S. Now, we're looking for what happens after so this is showing us from 1999. Right, so if you notice, and I know that I'm still kind of far away, but this is years since 99. So 1 year since 99, that would be the year 2000, 2001, 2002, 2003. So let's pick a year that's kind of off into the future. Let's pick a year like 2020. And the book is actually going to use the example of 2013, I think. But let's use 2020. And so 2020 is actually going to be 19 years from 1999, right? 19 years after 1999, I'm sorry, 21 years after 1999 will be the year 2020. So I want to figure out how many movie screens are going to be around the year 2020, which is 21 years after 1999. So my x is going to be 21. My question is, what's the y? So we'd go y equals 0.25 times 21 plus 36.5. Now remember that this answer is in the thousands, right? And so I'm going to go 0.25 times 21, and this is going to give me 5.25. So y equals 5.25 plus 36.5. I'm then going to add these two together, and I should get y equals 41.75. Okay, so in the year 2020, and I'm going to come back to this graph. Sorry, made a mess over here. Come back to this graph, you'll see that this is now, right, we're looking in the thousands. So in the year 2020, according to this prediction, I should have 41,750 screens, right? This is now 41,000 is what we're talking about there. So the idea is that I'm taking this and I'm substituting it for x. Now I can't put 2020 in there because that would mean my prediction equation is starting from year 0. And that wouldn't make a lot of sense in terms of movie screens, seeing as how movies weren't invented until many years after year 0. So we're going from 1999, and we're counting 1999 as our year 0 for this particular equation, which means that there were this many screens around in 1999, and then from there we now know that it's going to grow to this, or we're predicting that it's going to grow to this in the year 2020. All right, that's all I got for you today on prediction equations. Thanks very much for watching the video. Don't forget to do the problems on the bottom of the page. I'll see you in class.